Hey everyone, thanks for tuning into this video. This is optimized batch processing for scale and save up to 90% on compute by running AWS Batch on Amazon EC2 Spot instances. My name is Chad Schmutzer. I'm a principal developer advocate for the EC2 Spot team. Here's my contact information, my email address, and my Twitter handle if you'd like to follow me. I'd love to hear from you and get feedback on the topic here that we're about to discuss. A little bit more about myself. Again, contact information here. I'm always happy to hear from those of you that view content, and I'd love to gather your feedback and learn how we can make things better. Again, I'm a principal developer advocate for the EC2 Spot team. I'm based in Southern California. I maintain a plugin for Jenkins, which is the Jenkins EC2 Spot Fleet plugin, and I also maintain a GitHub repo focused on publishing examples and demonstrations and all kinds of goodies inside of this EC2 Spot Labs GitHub repo. Please check it out if you have a moment. Been with AWS for just under 7 years now, so I've been helping with Spot customers and helping public sector customers, and just been having a lot of fun helping customers, save at scale. And when I'm not doing compute work, you'll find me on the Little League field helping coach my son's team. So, anyways, a little bit about myself. So let's get into this. What we're here to talk about is uh, basically three things, which is AWS Batch, right? Let's talk about the key concepts of Batch, how to use Batch successfully. Let's talk about Spot instances, what they are, key concepts, how to use them successfully, and then let's figure out how to put them together. And at the end of the day, I hope you really find that this is quite an easy process. And there's a couple of things to keep in mind and a couple of buttons to push, and then we'll do a demo here and show you how it all fits together. So let's jump into this. Let's start out with talking about AWS Batch and level set. What is Batch? Well, Batch is a fully managed batch processing service. There's no software to install. There are no servers to manage. You just tell Batch what you need. Batch will automatically provision, manage, and maintain and scale your infrastructure for you so you can just run your jobs and get your work done focused on your applications and the data processing that you need to do. What's neat about Batch? Well, it's fully integrated with AWS, right? So it's natively integrated with the entire AWS platform. You can securely, interact with your jobs and the services that Batch interacts with in a secure way, including services like Amazon S3, DynamoDB, and Recognition. You can tie these all together and scale out your work for what you need. And finally, it's really, really good at cost optimization as well as resource optimization for what you need for your workloads, right? So it's going to automatically provision the resources. It's going to look at what you need. It's going to tailor those resources for your particular jobs, and it can do that on EC2 and EC2 Spot to help cost optimize as well as to optimize for performance within your environment. So let's talk about how this all works together. So who uses AWS Batch? Well, here's a sample set of customers that are really running at scale with Batch in the sense of the different areas. A lot of the autonomous vehicle machine learning and simulation areas are really running at scale with Batch. It's a great way to do that machine learning at scale, gathering a bunch of data and then processing it. That Batch just takes all that heavy lifting off the plate for you. Uh, Genomic sequencing, gene sequencing, a lot of companies are using Batch to get their research done, to scale their research out quicker in a cost optimized way as well. Weather systems and modeling, these are things again that are repetitive data analysis that all work together, that Batch can help you get done in a quick fashion. Financial markets, FinServ and risk analysis, right? Lots of data processing to be done, lots of dependencies on jobs, and Batch can help you with all of this. Oil and gas exploration, right? Where you have often these high performance, high throughput computing areas where you need to really work to get your data processed. Batch can help you with all of that as well, and there's many more. This is just sort of the tip of the iceberg, if you will. So what does a typical batch job architecture look like? Well, if we start from the top, typically data goes into an S3 bucket somewhere, and this slide is ahead of me already, but you put data into an S3 bucket. Um, the data in that bucket is then analyzed. So jobs go into a job queue. Those jobs go into a runnable state. The scheduler processes those jobs through the batch compute environment, and then the ultimate results of the job are then often pushed back into an S3 bucket. So the output goes back in. So kind of full circle here, but you see that, through this process, creating a job definition that includes details about your application image and the configuration that it needs, and the appropriate permissions through IAM roles and policies. Batch can take that data, process it, and then return the results back into the data source as necessary. So sort of a simplified view of how this all fits together. Now, what's new with Batch, and how has Batch been working to make all this process easier for you? AWS Batch recently announced a new thing called allocation strategies. Now, allocation strategies will basically allow you to um, take information about your jobs, and then Batch will automatically find the best capacity or best environment for it to run on by you telling it what's important to you. So in the case that you are going to use Spot, we highly recommend that you use the new Spot capacity optimized allocation strategy. So this strategy is designed to allow AWS to find the most available Spot capacity pools and then launch instances accordingly. And this Spot capacity optimized allocation strategy is available only for Spot. The best fit allocation strategy is basically the same behavior as before allocation strategies existed. Um, it will allow you to basically preserve backwards compatibility, so I won't focus on this one too much. But the other new one that we'll talk about here briefly is the best fit progressive, which is essentially the same as best fit. However, it does some neat things around progressively sorting through instances and capacity to pick the next best fit instance type for your particular workload. You can use best fit progressive with both on-demand computer environments as well as spot computer environments with specific use cases. But in terms of what we'll talk about today, we highly recommend that you focus on the spot capacity optimized allocation strategy within Batch. The other neat thing about Batch is that you can actually combine multiple computer environments to meet your needs for a particular workload. So in this case here, we're showing how a job queue can actually span jobs across both an on-demand compute environment as well as a spot computer environment. And each of these computer environments can have different allocation strategies associated with them. So in the case of this, we have a compute environment that's focused on demand, that has a maximum virtual CPU unit of 100. And then we have on the bottom another compute environment that's just for Spot. It's using the Spot capacity optimized allocation strategy, and it's allowed to use up to 2,000 virtual CPUs. So in this case, we can actually have our job system submit jobs into the on-demand compute environment. And if that ever filled up, those jobs could spill over into the compute environment too, which is Spot instances to help us save at scale. So after you reach a certain threshold in terms of your jobs, your scale will all be focused on using Spot instances. And since Spot instances help you save money, this is the most cost-effective way to scale up your environment here on Batch. So some concepts around Batch, we have jobs. Jobs are basically a unit of work that is executed by Batch via containerized applications that are then running on top of Amazon EC2 instances. These containerized jobs reference a container image. They have commands and parameters and potentially a zip file containing their application. And this can all be run on an Amazon Linux container by default. So it's very simple to submit a job, and that job goes into the job queue and then gets executed. Job definitions are similar to ECS task definitions if you're familiar with ECS. job definitions specify how the jobs are to be run. Um, and you can also override the parameters of a job definition at runtime. However, some of the attributes specified in a job definition include an IAM role to give permissions, your vCPU and memory requirements to run the job, the retry strategy. If the job fails, how will that job be retried? How many times? Are there any additional mount points you need for your job to run? Any additional information around container properties and environment variables also can be stashed in the job definition itself. Job states. So what happens once you submit a job to a queue? Well, once it goes into a queue, it basically runs through these states here, beginning with the submitted state, right? So that basically, once you submit the job, it goes into the job queue, it's accepted, but it hasn't been evaluated yet for execution. Now, if you do have a dependency on your job where there's a dependency on another part of a job to finish before it runs, then it would go into a pending state. If there are no other dependencies, the job would then typically go into the running state. Once runnable, not running. Once it has gone into a runnable state, that essentially means your job has been evaluated and it's ready for the scheduler to schedule the job and move it into the starting state. Once it goes into the starting state, it means that the scheduler is now in the process of scheduling your job onto a compute resource, one of the compute environments that we talked about earlier. It will then move into the running state, which means your job is actively running. Once your job finishes, it will either exit with a code 0, which means succeeded, or if it has a non-zero exit code, that means the job was canceled or terminated, or something failed there. So that's essentially the life cycle of a job within AWS Batch. So you also have the option of using workflows, pipelines, and job dependencies. Jobs themselves can express a dependency on the successful completion of other jobs or specific elements of an array job. You can use your preferred workflow engine and language to submit jobs. So lots of flexibility here. You know, we encourage customers to take a look at the options. And figure out what works best for you within your environment, but let Batch do the heavy lifting for the actual running of your jobs themselves. But lots of flexibility around dependencies and pipelines and workflows and things like that for your particular use case. Array jobs, basically within Batch, allow you to submit a large number of independent simple jobs, which basically allow many copies of that simple job to be run against an array of elements. So for example, if you have an array of jobs that need to be run, but each job requires slightly different parameters, you can do that. So you can say, submit this job through the array properties parameter. In this case, on this slide here, we're showing a size 30, but each of those jobs themselves will have slightly different parameters to allow that job to sweep through a data set. So if you needed to break your data set up, for example, and say each job will process a piece of that data, that's a great use case for using array jobs here as well. So that's Batch. Now let's get into the second part of this, which is EC2 Spot, and talk again. Since I said earlier, it's very cost effective to scale and optimize your workloads with Batch by using Spot instances. I want you to make sure that you understand what Spot is and how to use it and how it can be effective with using Batch. So just going back to the beginning, a long time ago, we launched an instance type called the M1 small. So ever since we first launched that instance type, we had spare capacity, right? Because we have to have capacity available to customers to be able to scale up and spin up resources whenever they need it. And so the side effect of that is that we have to have compute capacity that is unused, and that translates into spare capacity. After that, we added some new instance types, the M1 large, the M1 extra large. And so, we started to add additional instance types as customers asked us to. And so, it's really hard to keep up with having just the right amount of capacity for customers at any given time. And, it's a tough problem to solve. And so what this means is that we always have some set of spare capacity sitting around that isn't being used, that's idle. And this problem really has just gotten worse. Eh, Worse meaning better in the sense that we have more spare capacity for our customers to use via Spot. But the point is that over time it becomes harder to make sure that that problem is solved in the case of always having enough. Managing the amount of spare capacity that we have to match the demand that our customers are asking for in terms of our capacity. And so the end result is that with over 270 plus instance types, that means we're always going to have spare capacity somewhere, and we want to make that capacity available to you in a cost effective way. And so at the same time, you can purchase EC2 in different ways. The on-demand purchasing model is basically utility-based pricing for where you pay for compute resources as you need them. It's great for spiky workloads and while you're defining your workloads. Once you've kind of locked in what you need from a CPU perspective, you can think about using savings plans to help achieve a significant discount off of the on-demand price. Savings plans are great for committed and steady state usage workloads. Now, all this talk about Spot. Um, Spot instances are basically spare EC2 capacity that we've made available to our customers for savings up to 90% off of the on-demand price. So all that spare capacity we talked about in the previous slide is available to you to purchase through what we call EC2 Spot instances. And again, it's the same capacity that you would purchase with on-demand. Instead, you're purchasing it through Spot, and you're saving up to 90% off of the on-demand price. And Spot instances are great for fault-tolerant, flexible, and stateless workloads. And this is really why it's a great fit for things like with batch processing. So going back to the earlier slide as well is like, well, how much spare capacity do we have? Well, one hint at this is if you look at customers like Western Digital who have run, single uh, single HPC jobs that have scaled to over 1 million virtual CPUs just in a single region. And if you look at this case study here by Western Digital, it talks about their need for running massive amounts of hard drive simulations to sort of understand mean time to failure rates and things like that. By using Spot instances, they were able to actually scale to a significant amount of CPU and reduce their time to results from 20 days in their data center to 8 hours in the cloud by using Spot instances. So a pretty neat use case here for understanding how to scale with Spot and save money at the same time. Again, how much spare capacity is there? Well, I talked about the possibility of running over 1 million virtual CPUs in a single region. In the case of Western Digital, another data point I like to show is, on average every week, AWS customers are using more compute capacity on Amazon EC2 Spot instances than all customers were running across all of Amazon EC2 in 2014. So if you think about this, the amount of spare capacity is just growing at a staggering rate. And again, we want to make sure that customers get access to it and are able to save and scale all at the same time. So what do you need to know about Spot instances, right? So I've talked about the fact that it is spare capacity. It's the same infrastructure as the on-demand instances. It's just that we're selling it in a different model. It's available typically at 70 to 90% off of the on-demand price. Spot pricing can and does fluctuate slightly depending on trends and long-term trends in supply and demand. However, those price fluctuations are relatively smooth. We try to make them as infrequent as possible to allow you to focus on your application and less about around pricing. And remember, you will only ever pay what the current spot price is when you use a spot instance, and so that automatic savings is sort of built in and locked in when you use the product itself. Spot is an interruptible product. That means if at any point we need to take that spare capacity back and return it back to the on-demand demand customers, we can do that. And if we need to do that, we will give a 2-minute interruption notice to you to let you know that we need to take back that instance. So again, Spot instances are interruptible, and that is how they work, and that's the factor of what Spot instances are. And then finally, it's important to be flexible when you think about using Spot instances. And why is that? Well, our spare capacity is going to fluctuate depending on the demand for it. So there are different pools of capacity. Each instance type, each availability zone is a different pool of capacity, and that depending on which pools have requests put into them from the on-demand side, the spare capacity then is going to change depending on real time, where that spare capacity is. So it's important that you as a customer are flexible to say, well, I can use multiple instance types, I can use multiple availability zones, and then we help you go find where that spare capacity is. So talking about the pricing model here, a little bit about Spot. I have a screenshot here of an R4 8 extra large looking at Spot pricing history over the last 3 months. You can see in this case, pricing is relatively flat here. You can see tiny fluctuations over a couple of days here, but in general, spot pricing tends to remain relatively flat, and we want customers to just realize that we will always, allow you to pay the lowest spot price possible. You simply need to ask for a spot instance. If we have it available, we will give it to you, and then you will just pay the current spot price as you go. So I did mention Spot is an interruptible service. Your instances can be interrupted with a 2-minute warning when we need to take that instance back. However, we try not to do that if at all possible. And the result here is a combination of the fact that there's just so much spare capacity out there. Less than 5% of all running Spot instances were actually interrupted in the last 5 months. In the last 3 months. And so you can see, we're not in the business of just trying to interrupt you. If we don't have to, we will let you keep that spot instance for as long as we possibly can. So the work that you're doing to make your applications fault tolerant is a benefit to Spot in general, because if your apps are fault tolerant, then you can typically use Spot out of the box. And again, Spot is optimized for stateless, fault tolerant, and flexible workloads, and that's a pretty good fit for batch jobs in general. So one more thing to understand, right? Just about how our spare capacity works. So when you look at our data centers and you look at how we have capacity, let's take the C4 instance type, for example, here, and then we have availability zones and we have sizes. It's important to understand that each instance family, each instance type, each availability zone in every region is a separate spot pool, right? These are all separate pools of physical capacity. Available spare capacity is going to fluctuate in each of these pools. And so the more of these pools you can tap into and use and be flexible to use across, the more likely it is that you will find spare capacity out there. And Batch is designed to help you automatically find the spare capacity for you on your behalf. So the more flexible you are, the more you can say, well, I can use a C4 or an M4 or an R4, or an R5 or an M4 or an R4, et cetera, et cetera. The more flexible you are to run your jobs, well, the easier it is to find that spare capacity. So where can I get started with Spot? So customers that are running big data workloads are not very natural fit for Spot. CI/CD as well, web services and high performance computing, all very natural fits for Spot, as well as any containerized workload. And the reason for this is that these workloads are often fault tolerant, typically are flexible, are often loosely coupled, and are stateless. And the workload that we're talking about today, obviously, is batch processing. So these batch processing workloads are a very natural fit for Spot instances, because they often fit these categories here about being flexible and fault tolerant, loosely coupled, and stateless. So finally, to summarize, let's put this all together. So talking about AWS Batch with EC2 Spot instances, how do we make these fit? What are the best practices? Well, best practices include using the following keys, right? The first is to think about using EC2 launch templates. EC2 launch templates allow you to templatize parameters for your workloads. And in this launch template, we recommend that you enable Spot instance interruption handling in the user data. And I'll walk you through how to do this. It's a very simple one-line thing here. But this is the first thing. So in order for your batch jobs to be aware that an instance is going to be interrupted, you can enable interruption handling, and then no more jobs will be sent to an instance that has a pending interruption coming. You can also enable job retries, right? So whenever a job fails, you can tell batch to retry that job up to 10 times. So in the case that a job was interrupted or did not complete due to a spot instance interruption, you can have batch automatically resubmit that job for you. So it's just another parameter that you need to enable, but it's a great one to enable when you're running with batch with spot. So be instance type and availability zone flexible, right? So let AWS Batch find the optimal instance types and capacity for you, right? So when you submit your jobs, you're telling Batch how much compute resources you need, how much memory resources you need, and Batch is going to be able to go out and find the best match instance types wise as well as capacity wise for you. So that means the more availability zones you can feed to Batch, the more instance types you can feed to Batch, the better off you will be with having Batch be able to find that capacity for you. And then finally, um, use the appropriate batch allocation strategy. Earlier, I talked about allocation strategies within batch. If you're going to spin up spot, highly recommend you use the spot capacity optimized allocation strategy. It's been designed to find the most available spare capacity for you automatically, and it's just a very simple option to enable. So with all of that, let's head over and do a demo of how to submit a very simple batch, set up a simple batch environment using Spot as the underlying compute environment, and submit a very simple job, and just we'll walk through this whole thing. So let's get started here. All right, so let's jump into the console here and get our demo going. So I'm in the AWS Batch Console. You can find it by looking in services. If you wanted to just search for it like this, you can find AWS Batch, and it will take you to this. There is a like a get started wizard that you can run through if you want to. If I click on get started, it'll let me do a wizard that will help me set the environment up. For this demonstration purposes, I will skip the wizard and kind of do things by hand. Let me see how my font size is looking here. Okay, so let's take a look. I'm in the dashboard here. We can see that I don't show any computer environments here in my batch environment. So the first thing that we'll want to do is go to computer environments and start setting this up. Um, Actually, now that I think about it, let's do the launch template first, because I went through that first when I was talking earlier in the steps for following best practices for batch with Spot. So I'm actually going to jump over here in services to EC2 and open up a new tab. So let's do that. Escape out of this. All right, so let's jump to EC2. Oops, I think I went to ECS instead of EC2. There we go. All right, so in EC2, on the left-hand side, here we have visibility into the launch templates area here. So let's go ahead and create a new launch template, and we'll keep this simple. Let's just call this batch plus spot. We'll go to down here. We don't need to include a machine image. We will include an instance type. We will go ahead and just select C4 large here. And again, we can override this in the batch environment, so we can move forward here. Under network settings, I will go ahead and select the default VPC security group. And we can provide some tags here. We can tell the launch template to actually tag this so that we know these instances have the tag name of batch plus spot. Okay. And finally, under advanced details, this is where we'll actually set up the user data to actually handle interruption handling. So let me just show you what that needs to look like. Under the user data, all we need to do is actually set up this config here, which is to echo ECS enable spot instance draining equals true into the ECS config. So let's go ahead and just put that into the user data. So this means every time the instance launches, what we'll do is we'll actually tell the instance itself, the ECS agent, to automatically monitor for the spot instance interruption notice. And when it does that, to drain the containers off of this instance. And so this is the method that we'll use to enable interruption notice handling within our batch environment. So let's go ahead and create this launch template. All right, so I've got a launch template called batch dash spot here created. Now let's go back to batch and start doing our batch setup. So let's skip the wizard. Let's go to computer environments and create compute environment. All right, so here's where we'll get started. So computer environment type, we do want this to be managed. We want AWS to scale and configure our instances for us. Let's go ahead and name our computer environment. We'll call it batch spot. Here we'll create a service role. We can let batch automatically create a service IAM role for us. That way it can just take care of everything for us. I'll let it do that automatically. If you had one, you could select it. Otherwise, just let it create it for you. If you wanted to give your instance individual permissions, you could do that here as well. If you needed to talk to an S3 bucket or something, you can do that here by assigning an instance role. Or if you needed to access the instance, you could also provide an EC2 key pair. We won't do any of that because we don't need to. Okay, here under provisioning model, here's where we will select Spot. We want to use Spot for our compute environment. All the goodness of Spot that we just talked about. This is where we select it. Next value here of maximum price. This is where we will leave it blank because basically, remember, you only ever pay what the current spot price is. This is simply a way to cap your maximum spend per instance type, but we don't need to worry about that. I recommend you just leave this blank. We will automatically cap the maximum price equal to the on-demand price. But again, remember, you only ever pay what the current spot price is. So let's say the current spot price is 80% off of the on-demand price. That is what you will pay. So allowed instance types, here where we can tell batch to select the optimal instance types, because we're going to feed, remember, batch parameters around our job and our workload, and we're going to let batch figure out what the best fit is for our instance types. So when we select optimal, it automatically will look in M4, C4, and R4 instance types. We can also add some though too here, because remember, we want to be as flexible as possible. So let's additionally add the C5 family, the M5 family, and where's M5 family, and then also the R5 family. Because we want to be flexible, because we want to be able to find and have access to as much spare capacity as we possibly can. Remember, the more instance types we allow batch to use, the more likely it will be that we will be able to find that spare capacity. Under allocation strategy, this is where, again, we tell batch how to allocate the capacity for us. Since we're using Spot, we want to use the Spot capacity optimized, because batch is now going to be able to go out and find the most available Spot capacity given the list of instance types that we've allowed it to use, as well as combining it with the availability zones that we'll select here below. So again, highly recommended that you use the Spot capacity optimized allocation strategy. Let's use the launch template that we created earlier, the batch spot launch template. This is simply going to provide the user data for us, as well as some tagging on the individual instances. Remember, that user data is what's going to allow us to monitor for spot instance interruption notices, and to stop scheduling jobs on instances that have a pending interruption coming. Here's minimum vCPUs. If we want to have our environment scale down to 0 when we're not using it, we can leave this at 0. If we want to always have some capacity running so that we're always able to schedule and run jobs immediately, we can set this to the appropriate number. So in this case, I will set this minimum and desired to 16 virtual CPUs. That means batch will always keep a minimum number of 16 virtual CPUs running, and it will pick those virtual CPUs out of the allowed instance types. So it understands how much vCPU each of these is going to provide to the overall computer environment, and it will automatically keep that running for us here. Here's maximum vCPUs. This is the maximum amount of virtual CPUs that batch will ever scale up to. So if you were to put a ton of work into the job queue, batch could spin up to 256 virtual CPUs to get that work done. And you can simply control this automatically. If you wanted this to be whatever number the maximum you can use for your environment as well as the minimum, fine tune this to what you need. Down here in the networking section, this is where we're flexible across availability zones by defining multiple subnets we can use. So here in the Ohio region, here we're saying we're able to use US East 2B, US East 2A, and US East 2C. Remember, every single combination of availability zone and instance type is another pool of capacity that you can tap into. So the more of these you provide under allowed instance types and the more subnets you provide, the more likely it is you'll be able to find spare capacity. And then at this point, we'll just let batch go figure out based on the allocation strategy, which is the best pool of capacity to use. And that's really it. So at this point, let's go ahead and create our computer environment. So we now have a managed computer environment called Spot. It is in the status of creating. So if I hit refresh here, all right, so we've now got our computer environment set up. Its status is valid, and what this has done is it's basically gone off and spun up an EC2 autoscaling group comprised of instance types that are in the allowed instance types, and it's got a minimum value of 16 virtual CPUs and a maximum value of 256 virtual CPUs. So we're just going to let batch and the autoscaling group figure out how much capacity to spin up to give us the minimum, and then it will it's allowed to scale up and down between 16 and 256 virtual CPUs based on how much work is in the job queue. So let's go ahead and head over here and set up a job queue. Let's create a new job queue. We will call this batch spot. We'll give it a priority of 10. And I only have one job queue, but if we had multiple job queues, we could configure that here if we wanted to give priority over different compute resources. And we'll connect the batch spot computer environment to this job queue, and that's really all there is to it. We can see it has all of the parameters that we need, and we could simply say create job queue. All right, so now we have a job queue that we can use that is attached to the computer environment. Next up, let's create an actual job definition. So under job definitions, I'll click create. Let's give it a job definition name of batch spot. Now, here's where you configure the retries. If I want to enable automatic job retries, I can simply say job attempts, and I can set this all the way up to 10. So if there happened to be an interruption, I would allow this job to be retried up to 10 times. So this is a great thing to enable, especially when you're running on Spot computer environments. I can optionally give my my job roles, which enables additional permissions if I needed to. I'm not going to do that because I'm not doing anything fancy here. I'm simply going to use the container image of Amazon Linux. This is just the bare bones container image that I'll use, and I'm just going to do a simple echo hello hello. Sorry, I can't type today. Hello world for my command, and this is a very simple job that we will run. Each job only needs one virtual CPU, and it needs 128 megabytes of memory. I don't need any GPUs. Everything else is relatively simple that I'll be doing here just for the simple demonstration. So let's go ahead and create our job definition. So that's it. Our job definition is now created. I can create multiple revisions of it if I need to. Under actions, next to the create button, I have the create new revision, and I also have the ability to submit a job. So now that everything is stood up, let's check our auto-scaling group. Okay, here is our auto-scaling group that was automatically set up by batch. If I look under instances, we can see that we have 1, 2, 3, 4, 5 instances that have been launched. They're spread across multiple availability zones. And we can see though that this auto-scaling group is very, very flexible. It's able to use multiple instance types and multiple availability zones, therefore allowing us to automatically find the most available spare capacity for us to use. So now that we see that our auto-scaling group is up and running and ready to go, let's go ahead and head over here to back to batch. Oops, I don't need to change browsers there. And submit a job. Okay, so let's create job. Job name, we'll tell it batch spot. We can use the job definition that we created earlier, and we will use the batch spot job queue. We can simply run this one time, or I could do an array and tell it to run 300 times, something like this. But we'll just keep this simple for the demo, and we will just do a single job. We don't have any job dependencies. We can override the job attempts, but it was already set to 10 automatically. It's going to run the command echo hello world. It needs a single virtual CPU and 128 megs of memory. Remember, we can override these per job submission. But we won't. Let's go ahead and submit the job, and we can watch it run through the state that we talked about here of submitted, pending, runnable, starting, running, succeeded, or failed. Hopefully we'll land in the succeeded here. All right, so let's find out where it is. All right, so it did land in the succeeded pool here. We can see that this job did successfully run, and we can drill into the job itself and get some more information on it. It succeeded. It didn't take very long. And we can actually get the logs from our job from the CloudWatch console, and we can just get the results of our jobs in the output. And sure enough, here's our message, which is hello world. So our job did exactly what we asked it to. We asked it to echo hello world, and we know that this job ran on a spot instance as a result of running in our computer environment that is made entirely up of spot instances. So that's it for my demo. Quite simple, but hopefully very powerful for you to use to learn how to use Spot in your environment in a cost-effective way. I want to thank you very much for joining me for this time. If you have any feedback, comments, questions, if you'd like to see other kinds of demos, feel free to ping me either directly via email or on Twitter. Follow me, please. And if you want to see this entire demonstration done in a CloudFormation template with all the hooks around it, you can check out this GitHub this directory in GitHub repo and run this yourself via CloudFormation. All right, so thanks a lot for your time. Have a wonderful day. Take care.